Yo, what's up, everyone? Good morning. Um, and this is our last lesson of this unit, the sequences unit, and all it's going to be is review. So I'm going to give you today or tomorrow. I'm hoping like by the end of the day today, the quest, and all this quest means is that it's a test that I'm going to grade myself. I want to have at least one or two tests that are graded by me this quarter. But it's not as big as a usual test because it's only these two topics, arithmetic and geometric sequences. So this is pretty much what we've been doing this quarter. Um, and both these review sheets cover everything that's possible on the test, so you don't have to worry about any kind of random info. And every type of example problem, right? Because we have different kind of types of question. Those are the only types of questions you can see on the test. Okay, so if you're looking to figure out what the test is going to look like, I promise, and at this point you know that this is true, the test questions are going to look just like the example questions, the exact same format, just different numbers. This review set, our big focus is on sigma notation. So when we see the equation for the sequence and then also the sigma sign and what we can use that for and ultimately the sum. Okay, so this gets at the very end, we're going to do all six of these to some really tricky questions related to the sum formula. So I'm pretty sure that's one of the topics students think is the hardest. We have the formulas here, and we're going to use them. So yeah, we're going to get there. That doesn't reassure you that it's going to be easy, but yeah, I think going over it again should help. But yeah, first it just says look at the following sequences in sigma notation, and we want to write out the terms of the sequence and find its sum. So last time you can think that we were generally starting with the sequence and then like trying to find the equation from it. And we actually already did stuff that's similar to this in the last review set, where we want to take the equation and turn it into the sequence. Okay, so you don't have to do this anymore, but you can write out the parts of it that are necessary. For example, the common difference here is -8. And it's arithmetic, but you don't even need to write that as long as you can just recognize when you see it in this form, this stands for an arithmetic sequence. So the common difference is -8. And if I'm trying to write out the first term, we have to remember that that's when we plug 1 into the equation. Okay, so I'm going to do this in my head as -38. Just think that -8 times 1 is -8, and -8 minus 30 would give me -38. So that's my first term. And then the common difference just tells me where we're going from that first term. This is the first term, but we're going to go down 8 from there, so -46. We're going to keep going, and this is really important. The top number tells you how many numbers are in your sequence. Okay, so 5 is the number that I just kind of randomly tell you, make 5 if it doesn't tell you how many there are. But this is going to be specific if you see it. Okay, so if you're trying to write out this sequence, that stands for just 4 terms. And these are the 4 terms. And I hope that makes sense. The second part of this is really important for the logic. It's also saying to find the sum of the sequence. And first, you could do the sum using this formula, right? N over 2 with U1 plus UN. That would work. But I just want you to remember that you should always remember what the formula is even doing. We're trying to find the sum of this sequence, which means what happens if we add all the numbers up. In this case, there's only 4 of them. So you could just use your calculator, right? -38, -38, -46, -54, -62. Those are the 4 terms of my sequence. And the sum of them, if you just add them all up, is -200. Okay? So when you have larger sequences, 10, 15, 20, they're getting longer as the worksheet goes on, you're going to need to rely on the formula. And I hope that makes sense. If the sequence is only 4 numbers long, just add them up in your calculator. There's no reason to use the formula. But if we did use the formula, the n over 2 u1 plus un, very quickly be 4 over 2 . negative 38 minus 62, 2 times negative 100 equals negative 200. So I did that really quickly. I was like, is this even worth doing? But if you were to use the sum formula for this sequence, you get the exact same answer. But again, if the sequence is small, you're totally just allowed to add them up in your head. For this second one, we now have a geometric sequence, which in some ways is easier. Okay, we have 10 terms to this sequence, and we know that whatever number is on the outside is the first term, and the common ratio is whatever is being multiplied to n minus 1. Okay, and I think it's easier because we don't even need to do math to figure out the first term. It's given to us right here. So the first term is 8. The second term is 24 because all I did was 8 times 3. So I'm going to do this now 10 times. 8 times 3 times 3 times 3, like so. Okay, so that's my sequence, 10 terms, and they're getting way big, way quick. And the second thing it asks us to do is the sum. And I'm just going to add them up on my calculator to get this answer. Okay, so in my opinion, 10 is a good cutoff. If there were any more terms, I think it's too much to just write out even. I'm never going to make you write out more than 10 terms. And I'm also not going to ask you to use the sum formula. So again, we're looking for the adding up of these numbers. And if I wanted to add them up, I have this equation that we're going to use. But because it's a small enough sequence, I'm just going to put them in the calculator. And it's 2, 3, 6, 1, 9, 2. So that's a really big number. But what we know in this unit is that the numbers can actually get way bigger. They can get as close to infinity. So that's what's going to happen here. For the second set, the directions are very similar. It says, look at the following sequences in sigma notation. It's asking us to write out the first 5 terms and then find the sum using the formula. So just think that we're going to try to do the same thing here. But since these sequences are really long, meaning more than 10, I'm not going to ask you to write out all 15 of them, all 20 of them. I'm just going to ask you to write out 5, but then find the sum if we were to write out all of them. So again, let's just start by writing out the sequence. The common difference here is 5, and U1 is equal to 4. U1 is so easy to do, I think, hopefully you realize, because it's really just going to be this number minus this number, 5 minus 1 to get me that. So the first term is 4. The second term is 9. And I'm just adding up by 5 to get those first 4 terms. Now I'm going to use the sum formula to find the sum, okay? So I'm going to use this formula and this formula for the rest of it. And the arithmetic sum, and this should say sequence, my bad. An arithmetic sequence, the formula is not that hard. Okay, we haven't done it now in I think maybe 3 lessons or 4 lessons, but it's really not too difficult. N is our number of terms. So we have 15 terms. So if I'm trying to find the sum, it's going to be 15 over 2. And then the first term plus the last term. Now, I forgot, and that's no big deal. We don't know what this last term of the sequence is until we plug 15 into the equation. So if you want to find the sum of an arithmetic sequence, think that there's a bunch of numbers here. You find the first one and the last one, you add them up, and then you multiply it to the n over 2. Okay, so we got to figure out what that 15th term would be. So all I have to do is put 15 into the equation, right? So U15 is going to be 74, because 15 times 5 is 75, minus 1 gives me 74. And I hope that makes sense. But again, this formula is not that hard. What you really need to think, and what we're about to do, is that this is the hardest part of this quest, this one formula. Good, so it's going to be 78 times 7.5. And we get the sum here to be 585. perhaps I'm going a little quick, but I hopefully you guys are just feeling confident about all of this. If you ever need to find the sum of an arithmetic sequence, you're never going to get a huge number unless the sequence is like 100 or 1,000 terms. Okay, there's not really any shot for this to go up to infinity because the numbers aren't really flying that much either. Right, the 15th term is 74, which is not even that big of a number. Okay, good. We're going to carry on. This one is geometric, but we're still trying to do the same thing. First 5 terms, and then the sum. And we want to identify what we have. N is going to be 20. There's 20 terms. The first term is 15, and the common ratio is -4. Then I can take that first number and just keep multiplying the common ratio. 15 times -4, -60. Times -4, 240. I'm just going to go for this one in my head. But I got the last one wrong, I think. I don't know. Perfect. So again, I hope you understand what I was doing there. This is the first term, this is the common ratio, and then you just multiply. So I think that's like the easiest part. But now we have to find the sum of the sequence. And again, visualize that these are the first 5 terms and it goes for 20 terms. And it's geometric. So we're going to plug it into this formula. U1, and let's just plug it in first. That's going to be our strategy. And then go from there. The first term was 15. The common ratio is -4, which is being raised to the 20th power. And that's being subtracted by 1. And then on the bottom, it's the common ratio -1. So again, all I'm doing is plug into the equation. The first term, and I don't even have this memorized, like I have no idea. But the first term, then the common ratio raised to the number of terms -1. And this is so familiar, like if you do it enough times, it'll always be the same. And we have to remember that the hardest part is this part, this -4 raised to the 20th power. And what's so hard about that is it's going to be a really big number or a really small number pretty often. So -4 to the 20th power. And oh yeah, I wanted to do it on my phone. Yeah. Okay. I know a lot of you are doing like phone calculator stuff. Like you don't have your own calculator, and that's fine. So I wanted to use this sum formula with the calculator. So first, I hope you know that if you flip your calculator, you have a lot more options. And if you're trying to raise something to another power, so if we have -4 raised to the 20th power, you're going to do this x to the y. And how that works is you're going to do the first number, so -4. Then you're going to press xy. It'll stay highlighted, and then you press the second number, and that's going to give it to you. In this case, 1 trillion. So again, any number, and it's totally cool to use your phone calculator. -4, xy, 20, and we're going to get approximately 1.1 trillion. You would take that number and -1, and then multiply to 15. And then you're going to divide by -5. I messed up, and that's okay. We'll just do it again. -4 -1 times 15 divided by -5. And I think it's just that number, but negative. So -3 trillion. So basically what I wanted to say, and I'm going a little slow, is that if your number is ever really, really big, as in a trillion or a billion even, you can say infinity, okay? Because these numbers are kind of really difficult to get with, right? So in this case, we did -4 to the 20th power. That's pretty much -3. This whole thing is going to be -3 trillion, and I'm cool if you say it's infinity. Okay, I want to continue on. So we have one more geometric sequence to go over, and that's number 5. And our idea here is we want to just make sure we're as good with this formula as possible, even if we get a really big or really small number. So here, let's just plug in what we know. There's 30 terms to the sequence. The first term is 1000, and the common ratio was 1/4. And we're going to use that to write in my sequence, my first 5 terms. The first term was 1000, and then we're dividing that by 4. So the next is going to be 250. And then I'm just going to go decimal for the next few. 250 divided by 4 will be 62.5. Like that. It's good to visualize always. There's going to be 30 terms in the sequence that we're adding up, but most of the numbers are pretty small, right? So when we find the sum of this, it's not going to be a crazy high number. That's something to realize because the numbers are all getting smaller and smaller. It's converging. So when we use the equation, it's actually going to show us why that happens. So it's the first number, then we have 1/4 raised to the 30th power minus 1. And then on the bottom is 1/4 minus 1. So if you're going to do 1/4, and you can do it on the phone calculator now, to the 30th power, it's going to give you 0.0. It's going to give you basically 0. Okay. And again, let me just do it on the chat as well. It's going to give you like the smallest number possible. So 0.25 raised to the 30th. And if you see -19, -19, that means you're moving the decimal over 19 ways this way. So that's why it's basically 0. If I know this is basically 0, it's going to be 0 minus 1 times 1,000 divided by -0.75, or 1,333. So I think that stuff's hard. I'm not even going to lie. I don't even know if I explained it that well. And that's a difficult answer to get. But if you understand the fundamentals, hopefully you understand that this sequence is not going to be a crazy high number as the numbers go down. And if you have a diverging sequence, you're going to get a huge sum because just look how big the numbers are getting. My final thing, and I think I went a little long in this video, but that's fine, is what's going to happen if we have a really big arithmetic sequence. So again, U1 here, sorry, let's do common difference is -3. The first term is 4 because it's -3 plus 7. And there are 100 terms. And this is really easy to write out. The first term is 4, the second term is 1, -2, -5, -8. We're going down 3 for each of them. And we want to find what happens if we add up 100 of these numbers. But again, and I'm sounding like a broken record, and that's fine because this is my last time having to teach this. I just realized, so that's cool too. But yeah, I'm sounding like a broken record because I just want you to visualize the sequence. These numbers are getting smaller, but they're not going to get that small. Even in 100 goes, right? It's going to be a -11. We'll maybe even get to, -100 or a -300. But we're not getting to some number like 3,000. Okay? That's the big difference between these two sequences. And that's why when we find the sum of this, it's going to be a more normal number. So the sum is n over 2 u1 plus un. And we just need to figure out what the 100th term of the sequence is going to be. So n equals 100. So 100 times -3 would give me -300. Plus 7 will mean that the 100th term is -293. So I'm just going to plug all that in. 50, 100 divided by 2, 4 plus -293. So the sum here is -14450. And you don't really have to worry about anything ridiculous with this formula. It's usually going to give a pretty normal number. All right, that's that. It was a long lesson, but that's the end of sequences. I promise the test isn't going to be any harder than this. And I really, really appreciate you for everything.